Okay, so let's see how we deal with this. Remember, if we're going to be comparing two lists, we can combine together the means. I can combine together, the standard deviations, things like that. So if we had, let's see, where do I go with this? I think one thing we need to add to this book is page numbers. So I am on the second page of your notes of 5.6. Okay, so I'm on the second page. So far we've talked about this. And then the only difference between that is if I were to be subtracting Okay, so if I was comparing a couple lists together, if I was comparing two different classes, or if I was comparing guys and girls, if I was comparing scores of different lists of people, I could, and as long as they're normally distributed, I could combine their means together and I could modify what their standard deviations are. The one is if I'm subtracting them, realize that on their standard deviation, it's still plus underneath the radical sign. Still the information is going to be the same when comparing those. And the worksheet that we go through on worksheet 5.6, I think we can do this pretty easy with the information we have given. So I want to walk through this, and then after we're done with this, I'm going to have you do the quiz as the group. If you're not here, obviously, then they're going to come do it on themselves. So let's talk about these golf scores. So letter A on worksheets 5.6, and this is going to okay. So letter A says, for the four friends decided to play golf together. They have played for some time, and it is known that their scores are normally distributed the following means and standard deviations. Okay, so you have Jim, Linda, Joe, and Charles all playing. If they all play one more round of golf and each player's score is independent, fine. Okay, so right now Jim is just, we're worried about him. We're not worried about everyone else's scores. So we want to know what's the probability that Jim's score is going to be less than 83. And things that they tell us about Jim right now is his average is 68 and his standard deviation is a 9. Okay? So we just want to focus on Jim's score. So what I need to do is I have to find the z-score. So by looking at just what his average is and look at what his standard deviation is, he's probably going to score less than an 83. Okay, 83 is a little bit further out than one standard deviation. How do I know that? Is if I add 9 to the 68, I get to 77. 77 is still within, or he's more than one standard deviation out. So I want to find a z-score from here. So if I find his z-score, what this is going to do is I'm going to figure out what the chances is, and that would be the area underneath the curve. So we're going to figure out what his z-score is, which is right here. Look at the table in the back of the book and go from there. So I'm going to get 83, so his observed score. We want less than, so that's why it's the area to the left of our average. So 83 minus 68 over 9. And if you do the math, you're going to come out to 1.67. So the 1.67 means he's how many standard deviations above the average right now? Yeah, he's 1.67. So remember, a z-score is a way to represent a standard deviation when you start using decimals. So if I want to figure out the area of to the left of that, I just need to go to the table Z in the back of the book, or excuse me, table A in the back of the book. If I can find the back of the book. And I'm going to look up the score 1.67. I find this is 0.9525. So the chance that his score is less than an 83 is going to happen 95.25% of the time. Okay? So we're going to continue with these a little bit, that start talking about when are we going to start combining scores. We didn't have to combine scores on this, even though we have these 4 people with their golf scores. I'm just looking at Jim's score because Jim's score and Linda's score don't have any correlation with each other. They're independent from each other. So then if you go to letter B, it talks about Joe's score. And we have Joe's score is greater than 77. So on a normal curve, you're talking about the area this way. So if I was looking for an area that way, what do I have to do once I found the area under the curve? Yeah, so this is going to be, because it's over here, I'm going to go 1 minus whatever that area is. Okay, and that's going to give me the area to the right. So we know that Joe's score from our chart, Joe has a mean of 78 and a standard deviation of 5. Bless you. So right now, Joe's score wants to be bigger than 77. So where should we go with this? And then I use the table and then subtract it from 1. So Joe's score being above 77, is it going to be over half the scores? Okay, so his average is 78. So theoretically, I need to draw this a little better. So there's his average. So we're actually looking for that kind of area. Okay, and if you don't see the difference between red and green, then there's 2 colors out there, but go with it. So let's find his z-score first. So 77 minus 78 over 5. So that's going to give me negative 1/5, which is negative 0.20. So what does the negative indicate in this problem? Which side of the average? Okay. So I'm going to look up negative 2.00. Negative 2.0, it looks like 0.0. Oh, wait. Negative 0.2, sorry. 0.4207. So this number here indicates this area over here. In order for me to find the other area on the other side, I'm going to go 1 minus that. And that gives me what? How much? 57.93. So if we wanted to know how often Joe's score is going to be above a score of 77, it's going to be above that 57.93% of the time. Okay? If I'm going to find Charles' score is less than 72, Charles' score less than 72, we're still going to do a z-score and find the area. Being that we want less than 72, we just want to find the area to the left, which means I can look at the table in the back of the book. So that should be pretty easy to find. But then I want to get to Jim and Linda's score. So I'm going to skip letter C because it's going to be done the exact same way. But then I want to get to letter D that says, what's the probability that Jim and Linda total is greater than, is greater than 160. Okay? So, what do we know about Jim's average? 68. What do we know about Jim's standard deviation? Huh? 9, thank you. What do we know about Linda's average? 80. And her standard deviation? How much? 8. Okay. This is going to be one of the ones that we need to combine together. So in order to find the new mean, I'm going to go 68. We want their total score. That means their total. We're going to add them together. So we want to add their two averages together. That gives me 148. Okay? And in order for me to find the new standard deviation, I'm adding them together, so I'm going to go 9 squared plus 8 squared, which is 81 plus 64, which is 145. Let's see, did I do that right? What is the square root of 145? 12.04, thank you. So they have a mean, a combined mean of 148 and a new standard deviation of 12.04 as far as this goes. So now, if we were to think about this, we want to know their total score is above 160. Okay? So if I drew the new normal curve with their information, I'd have this being 148. I want to know their chance that they're going to get a 160 or greater on this test. So by that diagram, what do you know I have to do for the very end part of this problem? 1 minus whatever the area on the curve is. Okay, so now I can go ahead and find the z-score of the new combined information. So the z-score, remember, is going to be the observed. What's the observed now? What's the observed going to be? 160. What's their average? 148. The new standard deviation is 12.04. So if you do that math right there, I think it comes out to 0.997. And so I need to go find the normal score in the back of 0.997. 0.997 means it's to which way of the average? To the right, about 1 standard deviation. So 0.997, so 0.99 is what I'm going to look for. That's 0.8389, excuse me. So which area is this right now? That's this area here. Okay, so I need to go 1 minus 0.8389, which gives me what? How much? 0.16 what? So what's the chance that if Jim and Linda go out golfing, that their score is above their combined score is above a 160? It's going to happen 16.11% of the time. It's more likely to be a score less than 160, which would be the area to the left, but being that we wanted the area greater, I had to go to the right. Okay, and that's a perfect example of how you do this combining of normal scores. Can I do letter E? We have Joe and Charles' total score is less than 150. What's the probability that Joe and Charles score less than 150? So is this the z-score from the back, or do I have to go 1 minus the z-score? Is Just asking for the area to the left or to the right as it sits. To the left. So the table in the back of the table in the back, once we find the area, this is going to help us. So what do we know Joe's score to be? Or his mean? 78 standard deviation? 5. What about Charles? 77. And standard deviation? 11. Who's the better golfer just by looking at that right now? Why? You're absolutely right, but why? Has a higher average, so that's not the better score. What's that? Yeah. So Joe actually scores a lot more scores 68% of the time between scores of 73 and 82. 68% of the time, Charles scores between a 66 and an 88. Okay? So Charles is a lot more spread out with his scores. Joe seems to be a more consistent golfer. Okay, so we want their scores to be less than 150. So I have a new average. If I want to find the new average, I'm just going to add those averages together. That gives me 155, is that right? How do I find the new standard deviation? So 5 squared plus 11 squared. So that's 25 plus 121. 146, which is 12.08. Okay. So 12.08 is his new score. Or the new score, 155 is their new average. So I'm going to find the z-score of this. So I want their score to be 150. So again, if 150 is like here, and we want scores less than that, that's what our picture should look like. So I'm going to go 150 minus 155 over 12.08. This is going to be, what is 5 over 12.08? Say it one more time.
Negative 0.4139.
Okay, 139. What does the negative indicate then? It's on the left side of what? Not standard deviation, average. Okay, so is this going to be tougher for them to score this? Being their average combined average is 155. Is it likely that they can score 150? Yes. How likely? Well, let's find the area underneath the curve. Go to the table in the back of the book. Find negative 0.413. Negative 0.41. So when Joe and Charles go out golfing, how often are they going to score less than 150 points or 150 strokes on their golf games? 34, a little bit more than 34% of the time they will score less than a 150 on their combined score. Okay, does that make sense all the way up to letter E? Is there anything about that that's goofy that we need to work with? Because the last one, so I want to show you, really do have a nice influence on a lot of data collection types of things. It's easy to get lost in it if you don't see the first little trick. Okay? So on this one, we're like combining two people's scores and we're given a certain score. What we're going to get to next is we're going to compare people's scores to see who is better than the other, or who scores more often better than the other. So letter G says, hey, what is the probability that Joe scores less strokes than Charles? Okay? So we want to know the probability that Joe is less than Charles. So here's the trick. Okay, here's the trick you want to have here. You want to realize that what happened? What did I do? J stands for Joe, C stands for Charles. What did I do algebraically? Right. So if Joe has a smaller score than Charles, then Joe minus Charles would have been the higher score, is going to be a score that's less than 0. Okay, so when we are doing our z-score, we are now going to plug our observed value of 0 in for our z-score. So what was Joe's average, or Joe's mean? What's Joe's mean? 68. Standard deviation for Joe.
78, sorry.
Oh, this is a 78? Okay, yeah. Sorry about that. What is his standard deviation for Joe? Huh? 5? All right, and then for Charles. Charles' average. 77. His standard deviation. 11. Okay? We're subtracting these two now from each other. So I'm going to subtract the averages. So I'm going to go 5 minus 11, which is going to give me what? -6. So this is my new average. Okay, as far as the math problem goes.
That's standard deviation.
Oh, why did I do that? 78 minus 77, which is possible. Thank you. Okay. Whoa. 77. Hey, Cupcake. Thank you very little. Let's see. He is here, and he is here too.
All right, thanks.
Uh-oh. Uh-oh. Coach wants to see you on free time, so it can't be that bad. All right, so 78 minus 77 gives me a positive 1. That's my new average. That's my combined new average. Standard deviation is still going to be 5 squared. It's still going to be a plus sign. We don't subtract them. 11 squared. 25 and 121 is, what is square root of 146? How much? How much? Thank you. Okay. So, where it's kind of strange to think about this problem is we are subtracting the two. So we're taking averages of 78 and 77 to get a new combined average of 1. Okay, but we're going to take this and find the z-score of it. So I have my new observed minus the 1 over standard deviation. That's going to give me -1 over 12.08. Help me out on a calculator, somebody, please. What does that come out to? Negative what? 827. Okay? So, that's what we need to look for as far as your z-score in the back. So negative 0.08, negative 0.08, is roughly 0.4681, which means 46.81% of the time, Joe's score will be less than Charles' score. Okay, so 46.81% of the time, Joe will get a score lower than Charles. So what's the trick on this one? Realizing you can use a little bit of algebra to move things over to have it less than 0. Okay, then your 0 becomes your observed score. Notice I'm not going Joe less than J minus or less than C and trying to get a z-score from that. I'm doing algebra, moving a score over, getting an observed score of 0, and moving from there. Okay, and I think we can go to. Can I skip to J, or do you need me to do I? Huh? Good. All right. So skipping to J, and this will be my last one. Okay? We want to know the probability that Joe and Charles, their total is going to be less than Jim and Linda's by 15 points. Okay? So we want Joe and Charles' score to be less than Jim and Linda's score, less than 15. Okay? So, help me out. What is Joe's average? What is Joe's average? What's the standard deviation?
5.
What is Charles' average?
7.
And his standard deviation?
11.
Okay? Being I'm adding these together, I'm going to combine these together first. So J plus C. So my new average of these guys is going to be 78 plus 77. How much? 155. And then their new standard deviation is going to be the square root of what's the new standard deviation? 12.08. Okay? So I'm going to keep this with these guys. Talk to me.
I just wondered, when you're adding together the means, how do you know when it's subtraction?
You're gonna see it right here because this is gonna do the best of both worlds. Okay, so all I did right here is I took Joe and Charles. I'm taking care of their stuff right here on the left. I'm not messing with Jim and Linda yet.
Yeah, but on the last problem, you subtracted the averages.
Oh, okay.
I know which one to do.
Oops, I'll go back. Okay, so it was Joe is less than Charles. So being I did algebra to move this over to this side, it became subtraction. And then I would subtract the averages. The standard deviation is going to be done the same way each time. It's going to be, standard deviation squared plus standard deviation squared, take the root of that. But because this was, I had to move Charles over, it was Joe minus Charles is less than 0. So that's when I went ahead and subtracted them. On this one, it's going to do both. I want to know what Joe and Charles' combined score would be. So I had to add it here. And now I'm going to find Jim and Linda's. And once I have the new, because this is the information that I'm going to use for Jim and Charles, or Joe and Charles. So now I want to do this over here. What is Jim's average? What is Jim's average? 86. His standard deviation is what? 9? Is that what it is?
Yeah.
Okay. And then Linda's is what? 80, and her standard deviation? 8. Okay, so now I'm going to go through that whole thing for these guys. So again, we're adding them. So I'm going to get 86 and 80.
No, 68. Oh,
Wait, am I okay? So,
wait, Jim is 68.
oh, Jim is 68. Did my dyslexia kick in nicely? Standard deviation is 9? Okay. What is 68 and 80 added together? 68 and 80 added together is 148. Okay. new standard deviation is going to be root 9 squared plus 8 squared. So that's 81 plus 64. 81 and 64 added together is 145. Square root of 145 is 12.04. Okay. Okay, so this and this are now going to be combined together. So how would I set this whole problem up to give me something less than 0? What is moving over?
Do you add 15 to the average?
We will. We're going to get there. So how am I going to move this over to the left side? What's taking place? So J plus C score. So I'm going to add here, but then, let's see if I can make this make sense. Back to this. So this, I'm going to call X. This, I'm going to call Y for right now. So that means that I'm going to have X minus Y minus 15 is less than 0. X minus Y minus 15 is less than 0. Okay, so X is this score here. Y, you can't see it, it's down here. It's down here. I go to the split. So here's my X scores, here's my Y scores. Now I'm going to subtract. So I'm going to get mu equals 155 minus 148, which is 155 minus 148 is 7 minus the 15. 7 minus the 15 is how much? Negative 8. So that's going to be my mean. I'm going to plug into my z-score. My standard deviation. I'm going to take this one and this one. So if I find my new standard deviation, I'm going to go 12.08 squared plus 12.04 squared. Square root of that. I need help on that. I can't do it on in my head. Square root of that. Not divided. Comes out to 12.08.
Wait, squared?
So you did this squared plus this squared.
Oh, yeah.
That's
This squared
17.05.
17.05. Okay, so now I can find the new z-score. Okay? So again, we're talking less than, we're talking the area to the left. My observed z-score, I'm going to plug 0 in for my observed, minus my new mean, which is going to be negative 8. So I get 0 minus 8 over 17.05. So negative is positive. So that's going to be 8 over 17.05. So what's 8 divided by 17.05? 0.4692. So we're going to round this to 0.47. So that means it's to the right of the new average. So if I go to my score in the back of the book, 0.47. $68.08. So 68%, more than 68% of the time, Joe and Charles will have a score less than Jim and Linda, and they're spotting them 15 points. Okay? So if you're that gambling type out there, saying my partner and I will take on your partner and you, and we'll spot you 15 points. Sounds like a pretty good deal going. You're going to have Jim and Linda going, we'll take that action. And with your bet, you're going to win 68.08 times, 0.08% of the time. So Joe and Charles will score better than Jim and Linda if Joe and Charles gave them 15 strokes. That might be related to how sports books work. Huh. All right.